Hi everyone, this is the video for day number 83. It's going to be rotations and dilations. At this point you should have already watched the ed puzzles for rotation and dilation. And now I'm going to go over the actual lesson. Remember, these worksheets are on my website. You can print them and basically go along with me. And for tonight's homework is going to be a little bit different. On the Google Classroom, you'll see assignment packet number 83. And it's basically the questions from this packet. You're going to do, some of them are multiple choice and some of them are fill in. And you're going to do that as you're doing this video with me, and you'll just submit that in. Okay? All right, here we go. All right, so the first thing we're going to talk about is rotations. And a rotation is a transformation that turns a figure about a fixed point called the center of rotation. An object and its rotation are the same shape and size, but they may face in different directions. Notice may, so that means yes. Sometimes they could, and sometimes they do not. So it's easy to remember that rotation is a turn because you have that T. So T is going to stand for turn. Remember, we've done so far reflections, and we've also done translations. So reflection has the F, right? F is for flip, reflection, and translation has the S, that is for slide, and then your T for turn. So reflection has F for flip, translation has S for slide, rotation has T for turn. So it's a really just, you know, a little trick to help you remember all the different words with this. Remember, same shape and size, that is congruent. So that's a nice vocabulary word you really should be knowing. Same shape and size, that means congruent. Okay, so these are just a quick little examples. You're on a Ferris wheel, you're experiencing a rotation. Amusement park, those swings is a rotation. You can also see rotations in planets, so that's some science for all you guys. The concept of rotations can be seen in wallpaper design and artwork. And most important, remember that descriptive word, there's your T, rotations are turns. In mathematics, the rotation of an object is called its image. We all know that. Those are the ones that have the primes. If the original object was labeled with letters such as polygon A, B, C, D, E, the image may be labeled with the same letters followed by a prime symbol. Rotations can occur in either clockwise or counterclockwise direction. So clockwise is going to be to the right. So think of how like a normal clock would go. That's going to turn to the right. And counterclockwise is going to go to your left. There's a couple of degrees that they want you to know. In 8th grade, they want you to know what 90 degrees is turning on its side. So if I take, you know, my piece of paper and we turn it on its side, that's 90 degrees. And if we turn it upside down, which we did the other day, that's our rotational symmetry. Okay, that's our rotational symmetry. So I just split this up here. You can see 90, 180, 270, 360. And you have your original and your image. The image has the primes, and this shows 90 degrees counter. So let's go over that. So 90 degrees would be kind of like just one turn. Counters to the left. So it's basically if you took this piece of paper and you went to the left one time, well, what would this new figure look like? Well, C is up in the air now to the left, and A is to the bottom, like towards the right. And you notice that's how it is. C is up here and A is down here. So with rotations, you have to know their turns. You have to know clockwise is to the right, and you have to know counterclockwise is to the left, and then you have to know the different degrees. So 90 degrees, basically you're turning it once, and 180 you would turn it twice, and then of course there's 360, which 270, which is 3 times, and 360, which is 4 times, a complete circle. All right, so now we're going to move on to dilations. This is the second one in the packet. So a dilation is a transformation that produces an image the same shape but a different size. So this is the only one of the 4 that is actually a different size. And this vocabulary word is called similar. So same shape, different size is similar. Dilation is used to create an image larger. It's called an enlargement. Smaller is called a reduction. Okay, you are probably familiar with the word dilate as it relates to eyes. The pupils of the eyes were dilated. As light hits the eyes, the pupil enlarges or contracts depending upon the amount of light. This concept of enlarging and contracting is called dilations. So the washers shown in this photo illustrate the concept of dilations. You notice that basically all of them are a circle, meaning they're all the same shape, but all of them are different sizes. So same shape, different size. Again, dilation is the only one that changes size. So for dilation, there's a lot more math that goes with it, but it's not too bad, I promise. So you want to know the vocabulary word scale factor. And scale factor is what you're going to multiply by. So dilation is multiply. Kind of helps. What's kind of good is actually, remember, when we talk about the to distribute something, we always say distribute. Distribute means to multiply. Well, you have that D, and then you have the D here. So distribute, dilation, multiply. They both mean to multiply. And when you multiply, you're either going to get something that's bigger or smaller. Well, how do you know? If you're multiplying by something bigger than 1, well, it's called an enlargement. Because obviously, take any number, I'll take my favorite number 5, and multiply it by something bigger than 1, I'll say 3, and you get a bigger number than what you started out with. So 5 went to 15. Now, if you have something that's less than 1, I'm going to just add in but more than 0, because it doesn't make sense. You can't multiply something by 0 because then it's gone. That's going to be a reduction. So again, let's say I take that 5 and I multiply by the fraction 1/5. Well, that's going to get me 1. So the original went smaller. Okay, so anything bigger than 1 is an enlargement, less than 1 is a reduction. So again, scale factor means to multiply. So yesterday we talked a little bit about symbols. So this is going to have a symbol. They're going to use the letter D, and the letter D obviously stands for distribution, or excuse me, dilation. So the D stands for dilation. The number that is in the number sign spot is the number you multiply. So this number right here, that's going to be your scale factor. So I said scale factor is what you multiply by. So that little number there and the little number space, okay, the subscript as we call it, that's going to be your scale factor, and that's what you multiply by. So the number that is in the number sign spot is the number you multiply. For example, D2. The scale factor would be 2, so you multiply the dimensions by 2. Okay, so I want to practice a little bit with that right now. So find the image, that means the new point, of 6, 2 under the dilation of D4. So again, this little number right here, that's known as your scale factor. And with scale factors and dilations, what you do is you multiply. So you're simply just taking the 6 and multiplying it by 4, and the 2 and multiplying it by 4. So 6 times 4 is 24, and 2 times 4 is 8. And that is it. Scale factor is multiply. Notice those numbers got bigger because you're multiplying by something bigger than 1. All right, so now we're going to do the next one, and this is going to be a reduction. Again, this number right here is your scale factor. So you just take both of those numbers and multiply it by half. So half of -4 is -2. Half of -2 is -1. So these numbers got smaller because you're multiplying by something less than 1. This is a reduction. All right, so we can also apply this to shapes. So it says, what would the new dimensions of the rectangle below be after dilation of D3? So again, this right here is your scale factor. Scale factor is what you multiply by. So if I multiply this by 3 and this by 3, I get the new dimensions of 12 and 15. Okay, this is going to be a bigger rectangle because you're multiplying by something, again, that's bigger than 1. So this is going to be 12 and this is going to be 15. So those are your new dimensions. Again, all we're doing is multiplying. Same kind of thing, but now we're going to reduce it. Again, this is an enlargement, multiplying by something bigger than 1. And this is going to be a reduction. So we're going to multiply this by 1/3 and this by 1/3. Okay. I didn't show it before, but I'll show it on this one. Remember, to multiply by a fraction, you simply just use the ABC button. So 12 times 1 ABC 3. And that's going to get us 4. And then 6 times 1 ABC 3. And that's going to get us 2. So 4 and 2 are your new dimensions. This time I'm going to draw a smaller rectangle, 4 and 3, because this was a reduction. Okay, so now basically that's the lesson. So we're just going to practice with some random questions here with, again, rotation and dilation. So question number 1, What type of transformation for letter M is shown in the accompanied diagram? So if you notice, you went from a small m to a big M. There's only one type where the size changes, and that is B, dilation. Number 2, basically it says that they are similar. So you know that because they're different sizes. And you're going to go from the small to the big. Remember, this is your original and this is your image. Again, what's the only transformation where size changes? Dilation. Okay, question number 3. This looks very similar. Okay, same as that question. That's okay. Number 4, this is a great question. They love to ask it all the time on Regencies, test, everything. Which one is size not preserved? So let's talk about that. What does size not preserved even mean? Well, that means size is not the same. So which is the only one that size changes? And that's dilation. Hopefully you're catching on to this. Okay, rotation. Remember, we talked about that T and that descriptive word. And what does that T stand for? Well, it has to be a turn. So number 5 is a turn. Okay, next page. All right, number 6, we want to rotate it 180 degrees. Now notice they don't tell you which direction. They don't say clockwise or counterclockwise. That's because, and I'll take my calculator and show you, if I turn it to the left, so counterclockwise, 180, or if I turn it to the right, clockwise, 180, that means 2 stops. They're the same exact thing. So they're never going to tell you if it says 180. If you turn it left or right, it does not matter. All right, so focus on this right here. You want, and I'll zoom in a little bit. So you want to turn this upside down, kind of like our point symmetry that we learned in our Do Now the other day. Now, what does it look like? Memorize exactly what this looks like. Okay, so you have, to me, it looks like, I guess, a lowercase d. So now turn it right side up, back to normal, and which one did it look like? That would be D. Okay, the best description of dilation, remember, this is the only one where size changes. This is the only one where size changes. So that would be an enlargement or reduction. Remember, enlargement means bigger, reduction means smaller. Okay, number 8, again, without even reading, you look small to big. What kind of transformation is that? That would be your dilation. All right, number 9. So it says in the accompanied diagram, a triangle OAB is rotated counterclockwise. All right, so here we go. So now they're telling us that we're going to go to the left, and we want to turn it on its side. So this is to the left, and this is on its side. Okay, so you're focusing on this triangle right here. You've really got to focus. Okay, so if I go counter, again, that's to the left. I'm going to do one turn, one rotation. All right, so now really study what this looks like. This is the best thing you can do. You have a horizontal, it kind of looks like a right triangle, so we'll call it that. So your horizontal leg is now on top. Your horizontal leg is BA. And your vertical is this way. So B and A are on the top, and A and O are on this right side. Okay, so B and A are on the top, A and O is on the right side, and the slant is to the left. So B and A is on the top, A and O is on the side, the slant is on the left. All right, did you get that memorized? All right, so let's turn it now. And which one of those looks the same? Okay, so what I remember is that the B and the A were on the top, and the A and the O were on the side, and the B and O were slanted. So that is that one. So this is going to be your most complicated one, where they make you do the turning. You have to just try and just keep memorizing what it looks like, and then quickly turn the paper and figure it out. All right, so one more of those tough ones, number 10. Again, notice it's 90 degrees counter, which is what they tend to usually ask. So we're focusing on this triangle, okay? So you actually want to turn it. Turn it to the left and turn it on its side, okay? So now we have, kind of looks exactly like the other one actually, but B and C are horizontally across on the top, and C and A are vertically down the side. So B and C on top, C and A on the side, and your slant is BA. So BC on top, AC on the right. Horizontal, vertical. All right, memorize what it looks like. It's also in quadrant 2, by the way. And quickly turn. And which one had B and C on the top? Which one had B and C on the top? Oh, here we go. B and C on the top, C and A on the side. We have a winner. Hopefully those ones were not too bad. All right, number 7. Just got to focus on different size. Which one is a different size? That is always going to be dilation. Okay, here's some more multiplying ones. Remember, dilation means to multiply. So you just take both of these and multiply it by 2. Again, this is called your scale factor. And what are the new points we get? We get 6 and -4. Again, here's another scale factor question. So multiply. Remember, the D for dilation means to multiply. So for the scale factor, you're going to multiply this by 1/2 and multiply this by 1/2. Okay, so what's half of -6? I believe that's -3. What's half of 4? And that is 2. Right, so we have one with a rectangle. You see your scale factor of 2. I automatically know it's going to be an enlargement because the number is going to get bigger. So multiply both of these by 2. 6 times 2 is 12. 4 times 2 is 8. And that is our new shape. Right, next page. So far, so good. All right, so we got some pictures now. So we're just focusing on rotations. This is figure 1. This is figure 2. How do we get from this one to this one? So it wants to know if it's drawn 180 degrees or rotated 180 degrees. So focus on this one. So if I take this and I rotate it 180 degrees, well, it should be upside down. Is this picture upside down? No, it's not. All it did was it took it and it went like this. Took it and it turned clockwise 90 degrees. So this is going to be no, and this is going to be a 90 degrees clockwise rotation. This triangle has been rotating in a clockwise direction. So remember, this is your first one and this is the second one. Well, how do I know that's first? Because those do not have the primes and this one has the prime. So you're going from here to here. Has it been a clockwise? So clockwise is with the clock. That means it would turn this way. So this is yes. So you have your original and you have your image. Is it a clockwise direction? That would be yes. Okay, we really didn't do 45 degrees. This one says 45 degrees counterclockwise. So that's just going to be a little bit. Remember, clockwise, counterclockwise is to the left, okay? And 90 degrees is on its side. So what we're looking for is just a little bit, just a little bit. So counterclockwise would be to the left. So fish one, the one you're starting with, if you kind of just rotate it just a little bit, you can kind of see how it looks like it's landed to the, oops, can't see that. Slanted down to the left, and that's what this is. So from this one to this one. Okay, you went there, and you rotated it just a little bit, right? You took this, rotated just a little bit, and now it's going to look like that. So this one is going to be true. So this is our original, and this is our image. Okay, and our last page is going to focus on dilations. So is this an example of dilation? Yes. Well, how do you know that? Well, this one's a different size. Same shape, different size. These are similar. This is the only one, dilation is the only one that changes the side. All right, scale factor is what you multiply by. So under the dilation, shown at the left, we have a scale factor of 1.5. What will the question mark be? So basically, we're going to do 2. And we're going to multiply it by 1.5. And that gets us 3. And that's the answer. And last but not least, we have a big train and a small train. The length of the small train is 4 inches. Under dilation is scale factor 2. So you have to know scale factor means to multiply. What's the length of the large train? So you take your original, again, multiply by your scale factor, and you get 8. So 8 inches is what you're going to get. So hopefully this video helped you. Again, you want to go onto Google Classroom and you want to do the video or the assignments, packet number 83 that went along with this video, and submit it, and then that is it. So have a great night.